Hello friends, in this video we will talk about the calorimetry and bond energy. So bond energy, it helps you to figure out the total energy change of a reaction, and that total energy change be represented with delta H. That's equal to the sum of the energy of the bond broken minus the sum of the energy of bond formed. And you can use that bond energy table for this. Okay, so if you look into any question, like say, let us say this, we have to find the delta H based upon the bond energy. So what we'll do delta H equal to 2 times of the energy of HBr bond, because we have HBr bond here. So I'm going to write here delta H of HBr bond minus, this is what product, minus bond means these are the product which are formed. So minus the bond energy of hydrogen bond, and again negative delta H of bromine bond, and that's how we find it. So that that helps you to calculate the total change in energy, and you can look into the bond energy table and you can pick the value from there. And the second part we have is calorimetry, means calculating that how much energy is needed to reach the temperature of certain substance to a certain temperature under given conditions. So the formula that we use here for this kind of question is Q is always equal to mc delta T, where m is the mass. You can take in gram or kilograms, so grams, and then C is specific heat capacity of that substance, And what is the meaning of specific heat capacity of a substance? Is the amount of energy needed to raise the temperature of 1 gram of that substance by 1 degree centigrade. So that is called C. The amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree centigrade. And the units for C is joule per gram and then degree centigrade. These are the units. And the value for water is 4.184 joule gram centigrade. Okay, so if you have to do, like say for example, you have to do this question that we have here. It's say 5.6 gram of solid potassium hydroxide was added to 100 gram of water. The solid completely dissolved. This was accompanied by a rise of 30 degree centigrade in the water temperature. Calculate the heat of solution of KOH in kilojoules per mole of KOH. Okay, so how we can do it? First of all, you should know how many moles are involved when we talk about 5.6 gram. So find the moles of this, which is equal to mass divided by the molar mass of KOH. So it's 5.6 divided by the molar mass of KOH. You can check that. Let me quickly check it. Molar mass of KOH. It shows me on internet, it shows me 56.1. So write that it is 56.1 and on the top is 5.6. So when you do 5.6 divided by 56.1, you are going to get value as 0.1. So 0.1 moles approximately. Okay, now we have to find how much energy is needed to raise the temperature by 30 degrees centigrade of 100 gram of water. So we do it Q equal to mass, which is 100 gram. Okay, you can also take this 5.6 gram of KOH also consideration if you want to be more precise with your calculations. Okay, but otherwise we assume this is whole water, but just you can take this 5.6 gram also inside it. And then C is for water, as I told you, is 4.184, and then range of temperature is 13 degree. Okay, so it is 105.6 times 4.184, So again, I just want to check on internet what it gives me. So let me do it quickly. So 105.6 times 4.184 and times 13. So it gives me value 5743.8. So 5743.8 joules. Okay, and you can convert that into kilojoules. So this will be 5.7438 kilojoules. So this is the energy needed to raise the temperature, and they are looking here not only this energy. The question here is what is the energy kilojoule per mole. So as you see, the name indicates, you just have to do divide it by 0.1. Okay, so it should become now 57.44 kilojoule per mole, and that's your answer. So try this kind of question. This is about calorimetry and bond energy, and I will move forward with this next topic now. That's called energy change and how we figure out whether the reaction is exothermic or endothermic. So how we can do it? A reaction is exothermic if the heat is going from system to the surrounding. Okay, and endothermic is when the heat is going from surrounding to the system. Okay, so if we have a reaction of kind this, A plus B equal to C plus D and then plus some energy. That means what's happening? A and B are reacting and they are making C and D and they are liberating some energy. So this is your exothermic. But if the reaction is like this, A plus B plus energy, we write like this, it's giving you C plus D. That means you need energy to make this reaction happen. Then this is called endothermic. So if you are adding energy, we call it delta H as positive because we are adding it. And if the energy is going out of the system, we call delta H as negative. So in the reaction, wherever you see delta H positive, delta H negative, so you can decide on the basis of that whether the reaction is endothermic or exothermic. For example, you can see here first energy is endo, second is exo. Okay, and you can try this kind of tracking. Okay, and like see, it is written very clearly, but they can also write like this. The question can also be like this, which we use more often. Like for the following reaction, what kind of reaction is it? It's a delta H is 297 kilojoule per mole, and with the negative sign, that means this is exothermic reaction. And if I have to write it, it should be O2 equal to SO2 plus 297 kilojoule per mole. Okay, so this is, you should be able to identify whether the reaction is exothermic or endothermic. And then you can have some question like this: is the melting of ice an endothermic change or an exothermic? So melting of ice, it needs some temperature from the surrounding. Okay, and then it converts that to water. So it is an example of endothermic reaction. That's an endothermic reaction. Okay, so you should be able to identify by looking into the reaction or by looking into the wording that this reaction is exothermic or endothermic. Like say dry ice is solid carbon dioxide. It does not melt but instead turns from a solid into a gas in a process called sublimation. Is this change exothermic or endothermic? What sign would delta H value have? Okay, so ice is solid carbon dioxide. It does not melt. Okay, but instead of that, what it goes from solid into the gas. Okay, so gaseous state is normally having the higher energy, so this should be an example of endothermic, and delta H should be positive. Okay, so look into this kind of questions more. And the last thing that we are going to work in this video was factor that affect the rate of reaction. So whether the reaction is fast or slow, what are the different factors which contribute toward it? So that we have to work on. So nature of the reactant. So nature of the reactant talks about that how many bonds are formed, how many bonds are broken. So it can affect. So if the more bond broken and more bond formation is there, the reaction can be slow. But if there is less, then it can be fast. Second is the concentration. Higher is the concentration, faster will be the reaction rate, because then we have more reactant available for the reaction, and they can potentially convert it to the product. So we should say more effective collision. You know that when the particle collide and they collide in a specific orientation, then the reaction take place and we get a product. Temperature is related to the kinetic energy of the particles. So faster the particles move, higher will be the reaction rate. So it's directly proportional to temperature. And surface area is also contributing towards it. So more surface area means faster reaction. For example, say take a cube of sugar. So this is a cube of sugar. You try to dissolve it into water. And then you take the powder of sugar. So I know that powder will be able to dissolve faster because it has more surface or more particles available for the reaction. Wherever when it comes to cube, you see that only the outer particles are available for the reaction, inner are not. So it will dissolve slowly. So these are the factor which contributes. And then we have catalyst. So catalyst, as you know, that they directly don't interfere with the reactants and product. They might make some intermediate results, but at the end of the reaction you should be able to collect the catalyst as such back. Those are called catalyst, and they increase or decrease the reaction. So but they do actually, they change the reaction path, and they can lower the activation energy, so they can make the reaction happen faster. So these are the factors which contribute to the rate of the reaction, and I think that's good enough for this video. Thank you very much.